Arrow's theorem, here are some natural properties derived from a social welfare function. Definition 9.2. The social welfare function f satisfies unanimity if for every preference in L, f of such collections of preference is equal to just one preference. That is, if all voters have identical preferences, then the social preference is the same. Voter I is a dictator in social welfare function f if for all preference 1, preference 2 until preference n in L, f of such a collection of preferences equals to preference I. The social preference in a dictatorship is simply that of the dictator, ignoring all other voters. F is not a dictatorship if no I is a dictator in it. A social welfare function satisfies independence of irrelevant alternatives if the social preference between any two alternatives A and B depends only on the voters' preferences between A and B. Formally, for every AB in capital A and every collection of preferences from 1 to n and from 1 prime to n prime in L, if we denote the preference equals to f of the collections of preference from preference 1, preference 2 until preference n, and the preference prime equals to the output of the function f with the input preference 1 prime, preference 2 prime until preference n prime. Then A, which is less than B in preference I, if and only if A, which is less than B in preference I prime. For all I implies that if A is less than B, if and only if A is less than prime B. The first two conditions are quite simple to understand, and we could certainly want any good voting method to satisfy the unanimity condition and not to be a dictatorship. The third condition is trickier. Intuitively, indeed, independence of irrelevant alternatives seems quite natural. Why should my preferences about C have anything to do with the social ranking of A and B? More careful inspection will reveal that this condition, in some sense, captures some consistency property of the voting system. As we will see, lack of such consistency enables strategic manipulation. Theorem 9.3, arrow, every social welfare function over a set of more than 2 candidates where the size of A is greater than or equals to 3 that satisfies unanimity and independence of irrelevant alternatives is a dictatorship. Over the years, a large number of proofs have been found for Arrow's theorem. Here is a short one. Proof. For the rest of the proof, fixed F that satisfies unanimity and the independence of irrelevant alternatives. We start with the claim showing that the same social ranking rule is taken within any pair of alternatives. Claim pairwise neutrality. Let preference 1, preference 2 under preference n and preference 1 prime, preference 2 prime under preference n prime be two-player profiles, such that for every player I, A greater than B in I's preference if and only if C greater than D in I prime's preference. Then A is greater than B if and only if C is greater prime than D, where the greater function is the output of f of all the preference 1, preference 2 until preference n, and the greater prime is the output of the function f of preference 1 prime, preference 2 prime until preference n prime. By renaming, we can assume without loss of generality that A is greater than B and that C is not equal to B. Now we merge each greater than the I's preference and the greater prime in I's preference into a single preference greater than I by putting C just above A unless C equals to A, and D just below B unless D equals to B, and preserving the internal order within each of the pairs AB and CD. Now using unanimity, we have that C is greater than A and B is greater than D, and by transitivity C is greater than D. This concludes the proof of the claim. We now continue with the proof of the theorem. Take any little a not equals to little b which is in capital A. And for every 0 less than equals to I less than equals to n, define a preference profile pi to the I in which exactly the first I players rank A above B, i.e. in pi to the I, A is greater than B in J's preference if and only if J is less than equals to I. That is, the exact ranking of the other alternatives does not matter. By unanimity, in f of pi to the 0, we have b is greater than a, while in f of pi to the n, we have a is greater than b. By looking at pi to the 0, pi to the 1, pi to the 2, and so on until pi to the n, at some point, the ranking between a and b flips. So for some I star, we have that f of pi to the I star minus 1, b is greater than a, while in f of pi to the I star, a is greater than b. We conclude the proof by showing that I star is a dictator. Claim, take any c not equals to d in capital A. If C is greater than D in I star's preference, then C is greater than D where the greater than is the output of the function f of the collections of the 1's preference, 2's preference, and until n's preference. Take some alternative E which is different from C and D. For I which is less than I star, move E to the top in the greater than preference, the greater than in I's preference. For I which is greater than I star, move E to the bottom in the greater than in I's preference. And for I star, move E so that C is greater than E in I star's preference and E is greater than D in I star's preference. Using independence of irrelevant alternatives, we have not changed the social ranking between C and D. Now, notice that players' preferences for the ordered pair CE are identical to their preferences for AB in pi to the I star, but the preferences for ED are identical to the preferences for AB in pi to the I star minus 1. And thus, using the pairwise neutrality claim, socially C is greater than E and E is greater than D, and thus, by transitivity, C is greater than D.